My dear students, in this video also we are going to see some more properties of inverse trigonometric functions. That is property 8. The first property in the property 8 is sin inverse of 2x into root of 1 minus x square is equal to 2 into sin inverse of x. Where modulus of x is less than or equal to 1 by root 2 or x lies between minus 1 by root 2 to plus 1 by root 2. Similarly, here sin inverse of minus 1 is equal to 2x into root of 1 minus x square equal to 2 into cos inverse of x. Sin inverse of second result, 2x into root of 1 minus x square is also 2 into cos inverse of x. X lies between minus 1 by root 2 to 1 by root 2 to 1. X lies between, for the second result, 1 by root 2 less than or equal to x less than or equal to 1. Okay. See, the first result we are going to prove. For the first result we have to consider sin inverse of x by theta. Substitute sin inverse of x equal to theta, therefore x equal to sin theta. From this x is sin theta, and you know the result for sin 2 theta, 2 sin theta cos theta. Therefore 2 into sin theta, this cos theta can be expressed as root of 1 minus sin square theta by an identity. So you replace sin theta by x, you will get 2x into root of 1 minus x square. So return side you have sin 2 theta. Therefore 2 theta equal to sin inverse of 2x into root of 1 minus x square. From this 2 into theta is sin inverse of x. Therefore 2 sin inverse of x is sin inverse of 2x into root of 1 minus x square. Similarly, the second result, to prove the second result, substitute cos inverse of x equal to theta. For that x equal to cos theta. The same sin 2 theta is 2 sin theta cos theta. Here you replace sin theta by root of 1 minus cos by theta into cos theta because cos theta is x. Therefore, you get 2 into root of 1 minus x square into x, that is 2x into root of 1 minus x square. Left hand side is sin theta. So, 2 theta is sin inverse of 2x into root of 1 minus x square. The same result as in the case of the previous first result is theta is cos inverse of x. Therefore, 2 into cos inverse of x is sin inverse of 2x into root of 1 minus x square. That's all about these two results in the property 8. Okay. Next, property 9. In this property, we have some 6 additional results. The first property is sin inverse of x equal to cos inverse of root of 1 minus x square if x lies between 0 to 1. Close the interval 0 to 1. Next, second result is sin inverse of x equal to minus cos inverse of root of 1 minus x square if x lies between minus 1 to 0. So close interval minus 1 to 0, negative side. X is negative. See, I am going to derive the second result. Proof for the second result. First, as usual, you derive that. If I derive the second result, you can derive the first result by the same method. For that, you substitute sin inverse of x equal to theta. This sin inverse of x equal to theta. From this, x is sin theta. From this, what is cos theta? You know cos theta is root of 1 minus sin square theta by an identity. Cos theta is root of 1 minus sin square theta. But sin theta is x, you know, that is root of 1 minus x square. Sin theta is x, 1 minus x square. But cos of, we can write cos theta is cos of minus theta. Since theta is positive, cos of minus theta is also cos theta. So I can replace this cos theta by cos of minus theta. From this, minus theta equal to cos inverse of. For this problem, we just write from this step only you can get the first result. Cos theta equal to root of 1 minus x square. Theta is cos inverse of x. That is cos inverse of root of 1 minus x square. And you replace theta by sin inverse of x. You will get the first result. Equating these two. From this, cos of minus theta in the case of cos is positive. Cos of minus theta is cos theta. Therefore, minus theta equal to cos inverse of root of 1 minus x first result, you equate these two. Cos theta equal to root of 1 minus x square. Therefore, theta equal to cos inverse of root of 1 minus x square. And that theta is sin inverse of x. We get the first result here. Similarly here, cos of minus theta is equal, because cos theta, therefore minus theta is cos inverse of root of 1 minus x square. Multiplying both sides by minus, you will get theta is equal to minus cos inverse of root of 1 minus x square. And theta is sin inverse of x. Therefore, sin inverse of x is minus cos inverse of root of 1 minus x square. Since the second result, sin inverse of x is minus cos inverse of root of 1 minus x square. Next, third property. Sin inverse of x equal to, third property in the property 9. Sin inverse of x equal to tan inverse of x by root of 1 minus x square. Tan inverse of x by root of 1 minus x square if x lies between minus 1 to plus. Here, if x lies between minus 1 to plus 1. Less than 1. Okay? Here, we have to prove the third result. Here also, we substitute sin inverse of x is theta. To prove this result, substitute sin inverse of x equal to theta. From this, x is sin theta. From this, what is cos theta? Cos theta is equal to root of 1 minus sin square theta. You will get 1 minus x square. Sin theta is x. Cos theta is root of 1 minus sin square theta. Sin square theta is x square. Therefore, this is the case. 1 minus sin square theta is cos theta. Therefore, root of 1 minus x square. Instead of cos theta, I can write root of 1 minus x square. As in the case of the previous system. Now, cos theta is root of 1 minus x square. We know tan theta equal to, by trigonometry, sin theta by cos theta. What is sin theta? X. Cos theta is root of 1 minus x square. So tan theta equal to x by root of 1 minus x square. From this, theta equal to tan inverse of x by root of 1 minus x square. Tan inverse, sin inverse of x. What is theta now? Theta is sin inverse of x. You replace this theta by sin inverse of x, you will get sin inverse of x is theta, that is equal to tan inverse of x by root of 1 minus x square. You will get the result. Third result is derived. Okay? Now, again the fourth result in property 9, cos inverse of x equal to sin inverse of root of 1 minus x square. If 0 less than or equal to x, less than or equal to 1, and it lies between 0 to 1, throughout the interval, cos inverse of x is sin inverse of root of 1 minus x square. And cos inverse of x is pi minus sin inverse of x, sin inverse of root of 1 minus x square. These two results are derived as in the case of the previous results. Now I am going to derive the sixth result, that is tan inverse of x equal to sin inverse of x by root of 1 plus x square or cos inverse of 1 by root of 1 plus x square if x is positive. To prove this result, sixth one, put tan inverse of x equal to theta, therefore x equal to tan theta. You substitute tan inverse of x equal to theta, therefore x is tan theta. You know, to prove this result, tan theta equal to x, you know, what is 1 plus tan square theta? From this result, from x is tan theta, this is 1 plus tan square theta. You know 1 plus tan square theta equal to secant square theta by trigonometric identity. 1 plus tan square theta equal to secant square theta. Therefore, root of 1 plus tan square theta equal to secant theta. Taking square root on both sides. But tan theta is x, therefore this is 1 plus x square. 1 plus tan square theta becomes 1 plus x square equal to secant theta. So secant theta is root of 1 plus x square. Tan theta is x. So using these two ideas, first one, tan theta you know, you can write tan theta by sin theta by cos theta. This is equal to sin theta. 1 by cos is secant theta. This 1 by cos is secant theta. Therefore, tan theta equal to sin theta. What is it? Secant theta. Oh, 1 minute, sorry. Sin by cos. We want the result is sin inverse, you know. We want that. Therefore, this cos theta, tan theta equal to sin theta by cos theta, and that cos theta, from this I can express sin theta. From this I can get sin theta equal to tan theta into cos theta. This is tan theta. From this I get sin theta equal to tan theta into cos theta, but cos theta I can write it as 1 by secant theta. 1 by secant theta is cos theta. I can replace this cos theta by 1 by secant theta. This is nothing but cos theta. You know tan theta, what is tan theta? X. Therefore this is x. Secant theta is root of 1 plus x square. We derived tan theta equal to x and secant theta equal to root of 1 plus x square. So from this theta equal to the sin inverse of x by root of 1 plus x square. This is theta equal to sin inverse of x tan theta by secant theta is root of 1 plus x square. You will get tan x. This theta is again replaced by tan inverse of x. Therefore, this theta can be expressed by tan inverse of x equal to sin inverse of x by root of 1 plus x square. The result is derived. Again, the same idea, cos inverse of x. For this, I can derive the second one. You know, cos theta equal to 1 by secant theta. This is nothing but 1 by root of 1 plus x square. Because cos theta is 1 by secant theta is root of 1 plus x square. No. From this theta equal to cos inverse of 1 by root of 1 plus x square. Cos inverse of 1 by root of 1 plus x square. Got it. And if you replace theta by tan inverse of x again, you will get the result. Theta equal to tan inverse of x equal to cos inverse of 1 by root of 1 plus x. The two results are derived. This one and this one. Tan inverse of x is sin inverse of x by root of 1 plus square, and also cos inverse of 1 by root of 1 plus x square. From this idea, we can derive these two. That's all about property 9. Okay. Next, property 10 consisting of two results. One, 3 cos sin inverse of x equal to sin inverse of 3x minus 4x cube. X in the interval minus 1 by 2 to 1 by 2. And second one, 3 into cos inverse of x equal to cos inverse of 4x cube minus 3x, where x belongs to the interval of comma 1. Proof of first result. We know sin 3 theta by trigonometry identity. Sin 3 theta equal to 3 sin theta minus 4 sin cube theta, you know. This is the identity. Sin 3 theta equal to 3 sin theta minus 4 sin cube theta. You substitute for sin inverse x equal to theta and x equal to sin theta. So x is sin theta, you know. So in the result, sin 3 theta equal to 3 sin theta, that is 3x. 3 into sin theta is 3x. Minus 4 sin cube theta is x cube. So sin 3 theta is 3x minus 4x cube. And 3 theta equal to sin inverse of 3x minus 4x cube. 3x minus 4x cube. So what is theta? Sin inverse of. Therefore, 3 into sin inverse of x equal to sin inverse of 3x minus 4x cube. This is result 1. Similarly, proof of result 2. Put cos inverse of x equal to theta. From this x is cos theta. And you know the formula for cos 3 theta. Cos 3 theta equal to 4 cos cube theta minus 3 cos theta. This is the result. 4 cos cube theta minus 3 cos theta is the result for cos 3 theta. That is 4 into cos theta is x. 4 cos cube theta is 4x cube minus dx. So from this 3 theta equal to cos inverse of 4x cube minus 3x. From this 3 into theta is cos inverse of x. So 3 into cos inverse of x equal to cos inverse of 4x cube minus 3x. 3 into cos inverse of x equal to cos inverse of 4x cube minus 3x. These two results are derived from the two results, sin 3 theta and cos 3 theta. Okay, that's all about the property 10. So far we have seen all the properties of trigonometric inverse functions. Now we are going to solve the problems, exercise problems in the next video. Thank you.